everyone. This week we're going to be solving pages 24 through 28 in our packet. Page 24 is the first one we'll solve, so this is Monday's page for your packet. And we will be adding with mixed numbers. So a mixed number is a number that has a whole number and then a fractional part with it. So 4 7/8 plus 1/8. So we can look at this, and I know I have 4 as my whole number. I don't have a whole number over here. So I'm going to go ahead and put down what I have. So add up your wholes. So I have 4 wholes, and then I'm going to add up my fractional pieces. Because I have the same denominator, all I have to do is add the numerator. So I have 7/8 plus 1/8. That's going to equal 8/8. So your answer for this one is 4 8/8. But the correct way to write this is something a little bit different. 8/8 is equal to 1 whole. So what I have here really is 4 wholes plus 1 whole. And we know that 4 plus 1 equals 5. So the answer to number 1 is 5. Now we have number 8. Number 8 looks different than number 1 did because our fractions are not in the same unit. So number 8, I have 2 4/5 plus 3 1/2. So the first thing I'm going to do is add up my whole numbers. So my whole number here is 2. My whole number here is 3. 2 plus 3 is 5. So now I need to add up my fractional pieces. So I have 4/5 plus 1/5. So I'm going to add that back to my 5 that I added earlier. So I have 5 plus 4/5 plus 1/2. I cannot add these two because I'm not in the same unit. So what I'm going to have to do is get the same denominator in order to add these fractions together. So I have 4/5 plus 1/2. In order to come up with the same denominator, we're going to multiply by the opposite denominator. So the other number's denominator. So here I have 4/5. I'm going to look at the other fraction's denominator, and I have 2. So I'm going to multiply the numerator and denominator by 2. So now I have 1/2. I'm going to look at the other denominator, and I have 5. So I'm going to multiply both the numerator and denominator by 5. 4 times 2 is 8. 5 times 2 is 10. 1 times 5 is 5. And 2 times 5 is 10. So now I have 8/10 plus 5/10. 8 plus 5 is 13. And my denominator will stay the same. I'm not adding those two tens together. Now that I have the same denominator, I'm going to leave it. So 13/10 is what this is equal to. But when my numerator is larger than my denominator, that means I have a fraction that is greater than 1 whole. So in order to solve this one correctly, I'm going to have to pull out the whole and write the remaining fractional units in order to write it as a mixed number. So I know that 10/10 is equal to 1 whole. And if I pull out 10 from that 13, I have 3/10 left over. So 10/10 is the same as 1 whole, and then I have 3/10. But I'm not finished with my problem yet because I need to go back and add it to my original whole number, which was this 5. So what I have here is 5 plus 1 3/10. I can add my 5 and 1 together and get 6, and then I have 3/10. So your answer to number 8 is 6 3/10. Tuesday's page is subtracting fractions with unlike denominators. So you have to come up with common denominators in order to subtract. So number 1, I have 1/2 minus 1/4. I need to come up with a common denominator. The first thing I like to look at is I like to think, if I multiply 2 times anything, will it get me to 4? And I do know that 2 times 2 is 4. So what I'm going to do is I'm going to make my common denominator that 4. So I have 1/2. I need to change it to where I have a denominator of 4. I know that 2 times 2 is 4. So if I'm going to multiply it by 2 in the denominator, I'll also have to multiply it by 2 in the numerator to get an equivalent fraction for 1/2. So 1 times 2 is 2, and 2 times 2 is 4. So 2/4 is equivalent to 1/2. So I'm going to subtract 1/4 from the 2/4. So I have 2/4 minus 1/4. And that gives me 2 minus 1 is 1. And my denominator is going to stay the same. So my answer here is 1/4. Now we have number 12. Have 7/8 minus 2/3. Now I cannot multiply 8 times anything and get 3, and I can't multiply 3 times any whole number to get 8. So what I'm going to do here is I'm going to multiply each of these fractions by the other denominator. So I'll start with 7/8. I'm going to multiply both the numerator and denominator by the other number's denominator. So I'm going to multiply both the 7 and the 8 times 3 and subtract that from 2/3. Multiply the 2/3 times the opposite, the other number's denominator, which is 8, and that's going to give us the same denominator. So I know that 7 times 3 is 21. 8 times 3 is 24. So I have 21/24 minus 2 times 8 is 16. And 3 times 8 is 24. So now all I have to do is subtract. I have 21/24 minus 16/24. Okay, so 21 minus 16, remember you are just subtracting your numerators. Our denominator is going to stay the same at 24. So I know that 21 minus 16 is 5. So your answer to this one is 5/24. So remember, if they're not in the same unit, you have to get them in the same unit before you can add or subtract. Okay. Wednesday's problem set is subtracting with mixed numbers. This is page 26. So we'll look at number 1. I have 2 1/8 minus 1/4. Again, with this kind of number, you are going to do your work with your whole numbers first. But what I would like for you to look at is that 1/8. If I have 1/8, I cannot subtract 1/4 until I have the same denominator. So you might want to change your numbers to the same denominator before you start subtracting. So I have 1/8 here. I cannot multiply 8 times any whole number and get 4. But I can multiply my 4 by a whole number and get to that 8. I know that 4 times 2 is 8. So in this case, I'm only going to change this fraction to come up with a common denominator as that 8. So I have 1/4. I'm going to multiply it by whatever I can multiply 4 by to get to 8. So I know that 4 times 2 equals 8. So if I'm multiplying my denominator by 2, I also must multiply my numerator by 2 in order to get an equivalent fraction for 1/4. So 1 times 2 is 2, 4 times 2 is 8. So I have 2 1/8 minus 1/4. I'm going to rewrite that problem just like that. So 2 1/8, and I'm going to use my new fraction that's equivalent to 1/4. So I have 2 1/8 minus 2/8. So when we are adding fractions, we always start with our whole number and we go ahead and add those whole numbers up and put them over to the side. But when we're subtracting, we have to look at the fraction and see if we can just subtract those. So I have 1/8. If I have 1 of something, I cannot take 2 away. So what I'm going to have to do is pull out 1 whole and change it to a fraction. So if I take 1 whole away from that 2 will become a 1, and I know that I can change the 1 that I took away into a fraction, and 1 whole is equal to 8/8. So I'm going to split it apart like that. So this is equal to that 2. I just rewrote it like this. That way I'm going to be able to subtract. But I didn't just have 2. I had 2 1/8. So I'm going to write that down as well. So I have 1 plus 8/8 plus 1/8, and that's going to be equal to 1 9/8. And then I'll be able to subtract my 2/8 from that. So now that I can subtract the fractions, I can go ahead and write my 1 whole down. I'll still have 1 whole. Then I have 9/8 minus 2/8. I know that 9 minus 2 is 7, and my denominator will still be 8. So the answer to number 1 is 1 7/8. Now let's look at number 6. I have 3 1/6 minus 1 3/4. I know that I cannot multiply 6 times any whole number and get to 4, and I cannot multiply 4 by any whole number and get to 6. But I can come up with a multiple of both of these numbers. So I'm going to start writing down the multiples of both 6 and 4. So I have 6, 12, 18, and 24. Then I'll write down the multiples of 4. 4, 8, 12. And just like that, I've found the least common multiple, which is 12. So what I'm going to do is I'm going to take these fractions and multiply them by whatever number it takes to get to 12. So I know I have 1/6 here. I have 3 1/6, but I'm just going to focus on that fraction right now. I'm going to multiply both the 1 and the 6 by 2, because 6 times 2 is 12. So our denominator for each of these is going to be 12. 1 times 2 is 2. 6 times 2 is 12. So my equivalent fraction for 1/6 is going to be 2/12. Now for 4, I have 3/4. I need to come up with a denominator of 12. So I know my denominator needs to be 12 because that is going to be the least common multiple for both 6 and 4. So I know that 4 times something gives me 12. 4 times 3 is 12. So when I did it to the denominator, I'm also going to have to multiply the numerator by that same number. So I have 3 times 3, which is 9. So what I have here, I'm going to rework my problem. 3 2/12 minus 1 9/12. So now I can subtract because I have the same denominator. So I'm going to look at my whole numbers. I have 3 minus 1. Well, I know that 3 minus 1 is 2, but I need to look at my fractions as well. If I have 2, I cannot take 9 away. So what I'm going to have to do is take 1 from that 3 and make my whole number a 2. And then change the 1 I took away to a fraction. So I'm just going to rewrite this as a fraction. So I have 2, and I know that it takes 12 twelfths to make 1 whole. And then I had 2 more twelfths. So I have 2 plus 12 twelfths plus 2 twelfths. So I have 2 and 12 plus 2 is 14. So 2 and 14 twelfths minus 1 and 9 twelfths. Now I can subtract my whole number. 2 minus 1 is 1. And 14 minus 9 is 5. So 1 and 5 twelfths is your answer for number 6. Okay, so Thursday and Friday, you are going to be solving the same type of problem. So I'm just going to go over one type of problem that you'll see for these problems. So we'll look at number 1. I did not write this out because it's a word problem, so you can just listen and follow along in your packet. So number 1 says that Jim mails one package that weighs 3/8 of a pound and another that weighs 2/3 of a pound. What is the total weight of both packages? So you have to figure out what operation you must do here. So in this one, Jim mails one package that weighs 3/8 of a pound and another that weighs 2/3 of a pound. What is the total weight of both packages? That tells me I need to add these two fractions, but it wants us to estimate here. So I'm going to kind of talk through what goes on through my head as I'm estimating, and then I'll show you how to check your problem. So I'll look at 3/8 at first. 3/8 is 1 unit away from being 4/8, and 4/8 is 1/2. So I'm just going to estimate that 3/8 as being 1/2. So I'm going to add 1/2, and now I need to look at 2/3. Well, 2/3 is also actually pretty close to being 1/2. It's a little bit larger than 1/2, but it's pretty close. So I'm going to say 1/2 plus 1/2. 1/2 plus 1/2 equals 1 whole. So if I were estimating this problem, my estimate would be 1 whole. I can go through and check by multiplying by the opposite denominator and getting the fractions that I can add together. So I have 3/8, I'm going to multiply 3/8 by 3/3 because that's the other number's denominator. 3 times 3 is 9. 8 times 3 is 24. So I have 9 24ths. Now I'm going to come up with a common denominator for 2/3. Look at the other number. Other denominator. Going to multiply 2/3 times 8/8. 2 times 8 is 16. 3 times 8 is 24. So now I can add these now that I'm in the same unit. So I have 9 24ths plus 16 24ths. When I add this together, I get 25 24ths. And I can pull out a 1 whole from this and write my remaining fractional parts because my numerator is larger than my denominator. So if my unit is 24ths, I know it takes 24 24ths to make 1 whole. So I'm going to pull that out using a number bond. So I have 25 24ths. I'm going to pull out all the wholes I can. Well, I know that it takes 24 24ths to make 1 whole. And then after I pull out 24 24ths, I have 1 24th left over. So this is equal to 1 and 1 24th. So that is the answer to number 1. So this was the estimate, and this is how I checked my problem. So I was pretty close when estimating. When my estimate was 1 whole, and then the correct answer was 1 and 1 24th. So use what you know on these problems to estimate, and then you can always go back through and check to see if you were close with your estimation. I hope y'all are working very hard this week and y'all have a great week.